Good afternoon, everyone. My name is Erin Doherty. I'm a Senior Product Manager for CASE at Univar Solutions. Thank you for joining us for today's Spotlight webinar series with a focus on caulks and sealants featuring Dow Construction Chemicals. At Univar Solutions, we are serious about safety and start each meeting with a safety share. For today's safety share, we want to discuss the safe handling and storage of laundry products and other household cleaners. It's important to keep laundry products in their original containers and properly sealed after each use. Products should be stored out of the reach of children and pets. The original product packaging contains important use instructions and safety information should a spill, splash, or injury occur. Never combine laundry detergents with ammonia or other household cleaners, as some combinations can release irritating or dangerous fumes. And remember to clean up any spills immediately, wash your hands, and any items used to pour or measure products. During today's session, you will be able to submit questions via the chat box feature. The way you go about this is simple. First, click the question box as indicated in this diagram and write your question in the bottom box. Only the presenter will see the question, and the sender will be anonymous to other attendees. You can submit questions at any time, but we will address them at the end of the presentation. Today's webinar features Dow Construction Chemicals with a specific focus on waterborne acrylic technologies in caulks and sealants applications. Our presenter from Dow Chemical today is Audrey Liss. Audrey is an application chemist in the building and construction area at the Dow Chemical Company. She has more than 25 years of experience formulating and testing waterborne acrylic technologies and has worked across numerous market segments, including architectural paints, elastomeric wall and roof coatings, and digital imaging. For the past 15 years, she has served as a technical service and development focal point for Dow's acrylic, caulks, and sealant segment. Her current responsibilities include new product development and customer technical support for Dow's existing acrylic product line. She holds a BS in chemistry from Muhlenberg College. With that, I will now turn our discussion over to Audrey to share an overview of caulks and sealants.
Thank you, Erin, and good afternoon, everyone. My talk will focus on waterborne acrylic technologies used in the caulk and sealant world. So the agenda for my talk will involve talking a little bit about terminology and what we look at as a caulk versus a sealant, and how this industry is specification driven. I will touch base a bit on latex sealant design, as well as sealant formulating and specification testing. And in the end, the last section, I will cover a bit of sustainability and focus on Rowplex 4400, our latest polymer offering that can be formulated without the use of plasticizer. So I typically like to start off my overviews with a little bit of terminology. So these are definitions that we use in-house, and to try and differentiate between different types of caulks and sealants on the market, and based on their performance and what they can do. So a caulk is a substance when placed in a building seam or joint, creates a barrier to air, moisture, dust, or heat. Now, A sealant I like to refer to as a higher quality or really a higher performance type of caulk. And it is a caulk that does everything a caulk does, but it also can withstand extension and compression cycling without losing adhesion to the substrates it's attached to. So there are people use these terms interchangeably. There's really no right or wrong. And there are other terms that are used out there in the world, and it can vary by region. So first, like to talk a little bit about sealant property requirements. And this is not an inclusive list, but just wanted to focus on a smattering of different properties and focusing on dry performance versus wet performance. So I'm going to start on the right side here for wet performance properties. And these are generally properties of the sealant either in the tube, well, either after formulating, such as viscosity, what kind of target do you want your viscosity to be for your formulated sealant versus stability, and that gets into the wet state of the material in a tube or a pail. Will it remain stable over time? And wet performance property in terms of once you've gun out the sealant, will it slump or sag in the vertical joint it's applied to, or for that matter, horizontal. So those are various stages of wet performance properties. Now, once the sealant cures, there's a whole host of many different properties out there that can be tested on the dried or cured sealant, including but not limited to adhesion, joint movement capability, controlling the flexibility and the modulus for the desired application you're formulating for. Durability is key for exterior application. Mildew resistance can be key depending on the environment this is applied in, whether it's really humid, such as Miami in Florida, or in a bathroom, dirt pickup resistance, and paintability. So the construction sealant industry is a specification-driven industry. And I just took some pictures of some tubes here to highlight that with on a tube of caulk, there's a lot of words, including telling you about the sealant and warnings and a lot of other things, but oftentimes there will be a specification. So over here on the left, specifications exceeds ASTM C834. And on this middle one here, it's a little more buried in the bullets and not separated out, but this tube of sealant meets or exceeds ASTM C920 with a whole host of subcategories under it. So I just wanted to point out how this information is typically on the tube unless it is a non-specified sealant. And the industry is really driven by ASTM specifications. So there will be several slides throughout my presentation where I put performance categories across the top and then a different topic down the left side here. So in this table, I listed out non-specified sealant versus good, better, best. Good, better, best is not saying that any sealant is better than the other. It's really about targeting the application that you need this sealant to perform in. So it's really about performance. As you get towards the best, the better, best end, you are into ASTM C920, where there is a joint movement requirement to the specification. So for example, I have class 12.5 and 25 here, but there's also higher performance categories such as 3550 and 100/50. So just to give you a couple of examples, the differences between C834 and C920, I have 4 different properties on the left side here. So volume shrinkage is a required property of C834, but not of C920. Whereas peel adhesion is not required for C920, but it is a requirement for C920. Low temperature flexibility testing. This happens to be in both C834 as well as C920. However, while done in a similar fashion, there are different requirements on how to do it. So in this case, you use a 1-inch diameter mandrel versus a 1/2-inch diameter mandrel, and they are done at different temperatures. And one of the key properties besides adhesion in C920 is joint movement capability, which I mentioned at the beginning of this slide, and that is also part of C920. So on this slide, again, I have the different performance categories at the top, but this is divided out by chemistry. So what I'd like to point out here is that Dow Construction Chemicals plays in the vinyl acrylic latex and the acrylic latex area. So everything with the red X's is we sell polymers that can be formulated to meet these performance requirements. The other 3 common technologies are polyurethane, modified silicone, sometimes referred to as a hybrid, as well as silicone. And these tend to be higher performance, more specialty and commercial applications. And they tend to be in the ASTM C920 specification realm. And these areas, we sell products into them just within different parts of Dow. So what are some advantages and disadvantages of waterborne acrylic latex sealants? So some of the maybe more obvious advantages are that they're easy to use. There's not stringing that you might find with other types of chemistries. It's easy to clean up with water. They're low in odor, VOC, and toxicity, and they are paintable. They also can perform over a wide range and can be formulated at a wide formulation latitude. They are excellent for exterior durability, and typically they are lower in cost than other technologies. Some disadvantages. Now, the disadvantages are mainly around the fact that these are waterborne materials. So once a sealant dries down completely, there is usually some shrinkage involved due to the water content. Also, you have to take into consideration your environmental situation at the time that you're doing the application. So if you're applying these outside, will it rain later that day, and potentially you'll have rain wash out of your sealant? Is it above freezing outside? And then there's a humidity aspect that it just takes longer for them to dry in an extremely humid environment. So my next section focuses on latex design and selection. And so latex design, how do we get there? I'd like to share this slide in an overview because it presents all the different technologies or marketplaces that Dow plays in the world, and oftentimes I'm presenting to a broad audience as well. So pointing out here, sealants tend to be around in around +5 T last transition temperature, downwards of around -50 T sub G. Uh, these tend to be on the low side in order to have joint movement capability and do what the sealant is designed to do. These polymers were also designed to be used with plasticizer as well as other common raw materials. So what are some key considerations when designing an acrylic latex polymer? Things we think about are, well, the first thing we think about is what is the target application that we want this polymer to be formulated for, and what are the properties we need out in the end. And then we backtrack, and to designing the polymer, we think about the monomer type, the glass transition temperature, acid content, solids of the polymer, pH, and viscosity. And just I want to point out that the pH of our polymers are on the low side of about 4 to 5. And that's because we formulate at a low pH, and so that we incorporate all the raw materials together, and then we thicken up to a higher pH at the end, because obviously sealants that are not self-leveling will need to be formulated much thicker, but we want to incorporate everything, all the raw materials together. So 2 examples from that previous list is sometimes acid in the backbone is very necessary for adhesion, and specifically wet adhesion to glass as part of the ASTM C920 specification, in that the acid can react with the silane adhesion promoter that's in the formulation. So this is an example on top here where the polymer has less acid in the backbone and you get complete adhesive failure. Whereas in this sealant down below, there was more acid in the polymer backbone, and we got this cohesion splitting of the sealant, which is the desirable mechanism of failure. The other thing I mentioned were solids of the polymer. So higher solids are very desirable to minimize shrinkage. And typically our sealants in our portfolio range anywhere from 55 to 63% solids. And then once it's formulated into a sealant, and this is an example of a high volume solid sealant where you get some shrinkage, but it's pretty minimal, and that is quite a stable view. Whereas down here in a low solids sealant, you can see much more concavity, much more shrinkage, and this is a less desirable feature because it leads to more stress in the sealant. So again, how do we get there? The next slide, I'll focus on latex selection, and this is our product portfolio within Dow Construction Chemicals of the various products we have on the market. They are listed in order of highest TG down to lowest fast transition temperature, along with the solids. And then, as I showed on previous slides, different performance categories here. And P is pigmented, C is clear, T is translucent. And so this is an indication of what polymers can be used for different performance requirements. So if a customer comes to me and says, I'm looking for a polymer that just can fill a joint, and I'm looking for low cost, most likely I will recommend waterbased 86. If they are looking for something that they want to formulate without plasticizer in the formulation, and I will get into this much deeper when I talk about Rhoplex 4400 later, then I would either recommend Rhoplex 1950 or Rhoplex 4400. And as we dig into the details, I can, I can maybe get that down to one option, or maybe they might like to look at two options. And Rhoplex 4400, while it does meet ASTM C920 Class 25 specification, it also is capable of meeting Class 35 as well. To touch a little bit on the next few slides about just overall sealant formulation. So what's in a tube of caulk? So if you take a 1 pound tube of caulk, and that's approximately these days, it depends on the raw materials inside, there typically will be a lot of filler in there, as well as latex. And latex is really driving the performance properties in the end. There might be pigments such as TiO2 or a colorant in there. There's typically a thickener. In this case here, this is a polymeric type of thickener. We typically formulate with hydroxyethylcellulosic thickener because that is most efficient to get to the viscosity we need. There is very oftentimes a slug of plasticizer in there. It's very common to use. And then there are additional raw materials, such as what's listed on the right-hand side here. So to look at this from another perspective, if we look at, again, a C834 sealant versus a C920 sealant, both pigmented versus a translucent and a clear, as you move from left to right here, your acrylic latex percentage increases while your filler and pigment levels decrease. And we refer to sealants as having a pigment to binder ratio, or P to B. And this is a measure of how much filler there is in the sealant relative to the amount of dry polymer solids. And this gives people an idea of what kind of performance that sealant has. So below here, I just put down some very relative numbers. This is not set in stone, but I just wanted to show a comparison between the different formulations. For example, pigmented C834 sealants typically start at a P to B of about 3.0, but can go much higher than that. There are sealants that are as high as 4.5. Pigmented C920 sealants might start around 1.0. I've seen them as high as 2.2, 2.5 P to B. Translucent, because you have a very small amount of filler or pigment in there. Actually, typically just fumed silica will be less than 0.1, and then of course the clear does not have any pigment or filler in it, so it's 0. So an example of P to B, as it increases, and looking at elongation, as you increase the P to B here, you are decreasing the amount of polymer and increasing the amount of filler, so that your sealant film will decrease in elongation over time due to more filler in there. So I always like to show this picture to people because it clearly states the point I'm trying to make, or non-clearly if you want to go that way. Translucent versus clear caulks. So very often people will refer to what's on the left as a clear caulk, and I am going to call that a translucent caulk. So you can see light through it and there's something on the other side of the film, but you can't read what it is. Whereas on the right side of the screen, you can clearly see through the film and you can even make out the words. So there is no filler or pigment on this side, and this is translucent due to some incorporation of fumed silica, but um, there is no pigment or filler in there. De-airing sealants. Now this is key to formulation, and especially when testing performance properties, and is also key for real world application. So sealants are, like I said earlier, formulated at low viscosity, and then they are thickened uh, towards the end once all the raw materials are incorporated in. So by the time it gets to this thickened state, there's air entrapped in your sealant. These sealants need to be de-aired, preferably while mixing under vacuum, because as you can see here, since this is a translucent film, you can actually see all the air bubbles. Now, if you have a pigmented sealant, chances are, well, you won't see the air bubbles that are incorporated into the thickness of the sealant itself, but you may see bubbles on the surface. And air bubbles hurt two things. One, they hurt the appearance aesthetically, but more importantly, they hurt physical properties. So when we formulate and test in the laboratory here, we thoroughly de-air our sealants so that we don't incorporate air bubbles, and we test the actual bulk sealant material. Specification testing. So these are the two specifications that I mentioned towards the beginning of my talk, ASTM C834 and ASTM C920. And both of these specifications have various test methods within them that need to be followed, and then there are certain requirements that they need to meet. Within Dow Construction Chemicals, we have capability to do all of this testing. While we focus on these two specifications, there are other specifications that exist that might be more important for more specialized sealant applications. And besides the specification testing, we also do a variety of non-specified tests as well. The next couple of slides are just some pictures from the lab to give you a visual of what's going on during some of these tests. So this slide and the next slide are C920 spec tests, and this is the joint movement testing where we have a dried joint, which is in the joint tester here, and then it gets cycled over time at various temperatures. And here's a picture of it extended by 25% from the initial width of 0.5. So these are class 25 joints. They get extended at plus or minus 25. So another critical C920 test is peel adhesion, where we do a 180-degree pull, and this is done on 3 substrates, including glass, mortar, and aluminum, but we also do other substrates as well if the application is a different application or if the customer requests it. So another test is slump testing. This is also referred to as flow, slump, sag. People use the terms interchangeably. It is a test that is in C920 as well as C834. They are just done via different apparatus and at different conditions. So each test needs to be looked at individually to see. And what you basically want here is for your sealant to stay in this channel and not fall out of it. And over here, there's, I call this the marshmallow test in my head because there's a circular blob of sealant on the surface, and when placed vertically, we do not want it to slide down. The last picture for testing I have is tensile testing, and this is very basic testing that we do on an Instron or a Tamias Olson, and we typically do dog bones, and this is loosely based on ASTM D412. So now I'd like to focus a bit on sustainability and our latest polymer offering. And that would be Roflex 4400, which was developed to be a plasticizer-free polymer in formulating. So on the left here, there's some physical characteristics of Roflex 4400, low T sub G, higher solids, pretty typical density, viscosity, and pH to other polymers in our portfolio. So while 4400 offers sustainable aspects, including when we, let me go over that again. 4400 offers sustainable aspects and was developed as such to have green attributes, as using green raw materials over the traditional older polymers that we have in our portfolio. And so this was designed without using APE or surfactants, EA or AM. It's very low in formaldehyde and can be formulated to a low VOC formulation. It also is Green Circle certified. So the benefits of 4400 are that it can be formulated over a wide formulation latitude to meet for the customer to focus on performance versus cost. It can be formulated across the C920 specification, upwards of and including class 35, as well as ASTM C834 without the use of plasticizer. And I keep bringing up plasticizer because plasticizer has always been a common raw material used in formulating sealants. There's, even though one can formulate without plasticizer, it also is accepting of low levels of plasticizer to target higher P to B ratios, and it has excellent weathering characteristics. So without the negative effects of plasticizers, I'd just like to focus on that. I have several bullets here, and then I'll show you some pictures of what is here. And what happens is plasticizer is a low molecular weight material, and over time will migrate through the thickness of the sealant and deposit itself on the surface of the sealant, causing various issues. There's 4400 has an enhanced sustainability profile due to the elimination of plasticizer and enables greener type of sealant formulations without without using pesticides or in the formulation, it reduces dirt pickup, glossing, and paint discoloration of the surface, and it increases compatibility with various construction substrates that plasticizer will negatively interact with. So these are pictures of what I just mentioned and some of the negative side effects of plasticizers. So for example, in this first picture in the upper left is a sample of our different sealants containing plasticizer A, B, and C. So these are three of the same sealant formulation, just with different plasticizers in them, and then a plasticizer-free sealant on the left here. We made slabs in the laboratory, and after they dried, we used the same paint on all 4 slabs and just let them sit inside in the laboratory over an extended period of time. So the paint started out bluer on the left here, and as you can see, the colorant just starts washing away over time and to various degrees. And this is due to the plasticizer migration to the surface and interacting with the pigment in the paint formulation. Also, dirt pickup resistance. So this is a commercial building where the seams in the building here were filled with a sealant and then top coated with an elastomeric wall coating to get a uniform visual of the wall of the building. So what again happens over time as the plasticizer migrates to the surface, it can also create a sticky surface on the sealant. And once you have a sticky surface, depending on what the environment is like, will depend on how much dirt gets picked up on the surface. And then all of a sudden, you're going from an aesthetically pleasing, uniform looking wall to a wall that has these dark seams in it. I also mentioned substrate incompatibility for construction products. This is expanded polystyrene foam, and I basically took a drop of 2 different plasticizers, put it on the foam, and just let it sit there in lab over time. And time on this is weeks, if not months, and the hole just kept getting bigger and bigger. So this is another reason, depending on your application, why you would want a plasticizer-free sealant. And the last property I'd like to highlight goes back to paint, if you're applying that over top, and that's with the glossing look. So here we have 3 different sealants, 1, 2, 3. Dried the sealants, painted over with a flat brown paint. As you can see with sealant 1 and sealant 2, there is this sheen to it, the light reflection. So now your nice flat paint has a gloss to it. So if it's right next to something that's painted with the flat that doesn't develop a sheen, it is just not good looking or aesthetically pleasing. Whereas in channel 3 here, there's a plasticizer-free sealant, and as you can see, it remains a flat paint. There's no interaction of plasticizer migrating to the surface. Another larger example of plastic migration is with this siding panel that somebody took some sealant and decided to use it as a patch. So they took the sealant and they smeared it over the side of the panel to make it more uniform looking, and then they painted over it with this light blue paint. As you can see, due to plasticizer migration to the surface, you now have all these lighter whitish spots, and you have this whole mottled surface. So you can imagine what this might look like on an entire building. So plasticizer, again, while it's commonly used in sealant formulations, there are times that one will not want to use it, and Reflex 4400 can meet the needs for the desired property. So just in summary, I've talked a little bit about a caulk versus a sealant property requirements, and that fact that this is a specification-driven industry, got into latex design and Dow's sealant polymer product line, as well as sealant formulating and specification testing, and finished up with Vortex 4400 as our latest offering to formulate without the use of plasticizer. So this concludes my presentation. I appreciate your attendance, and now I'm going to pass back to Erin for questions. Thank you.
Thank you, Audrey, for a great presentation. At this time, we will now open it up to questions for Audrey or for Pat Rossiello, Senior Marketing Manager from Dow Construction Chemicals. As a reminder, you can submit questions via the chat box feature. First, click the question box as indicated in this diagram and write your question in the bottom box. Only the presenter will see the question, and the sender will be anonymous to the other attendees. At this time, our first question for Audrey is, why would or should someone choose a waterborne acrylic technology over a silicone technology? Audrey or Pat, could you answer that for us?
I'm here. I'm sorry, I had trouble unmuting myself. So really the main reasons for choosing a waterborne acrylic sealant over something like a silicone sealant is for ease of application and cleanup. It is the most used type of technology sealant for homeowners to use around the house and outside of the house. So you see a lot of them out on the shelves in like a Home Depot, home box store, a paint store, and they're really easiest to use for the DIY and contractor consumer market.
Great, thank you, Audrey. Our next question is, are there any specific application conditions needed for successfully using waterborne sealants?
Thank you. So I touched on this back at the beginning of the presentation with advantages and disadvantages of waterborne sealants. There are issues when applying outside and inside as well in terms of temperature. So you need to be above freezing, and I would say most likely above 40 degrees Fahrenheit. And you also have to take into consideration what the environment is on that day and coming up later in the day, so that if it's going to rain outside, you really want to avoid applying these waterborne sealants if it's going to rain within that day. And then inside, you need to be mindful of if you put them in a any room where there's higher humidity, such as a bathroom, or if you plan on taking a shower, you need to give a waterborne sealant time to evaporate, let some of the water evaporate and dry a bit before it gets attacked by water again.
For our next question, is buying the best sealant based on ASTM rating always the right choice for application?
So the answer to that is no. Everything is based on application. What application are you using that sealant for? Well, there might be a ASTM C920 class 20, or let's say class 50 sealant on the shelf. While it has great joint movement, because it has plus or minus 50% joint movement, it doesn't mean it's right for that application. So it can be, if you use an over-engineered sealant for an application that just requires a C834 sealant, then you're paying a lot more for a sealant that you don't need. It's over-engineered for this situation, but it's also might not perform the way it needs to. So generally inside buildings, let's say houses and low-rise buildings, you don't need a class 50 sealant in that application. What you more likely need is something like a C834, or if you're doing maybe crown molding where the wood will move a little bit over time, you more likely need a C920 class 12.5 performance as opposed to a higher performance. The class 50 and class 100/50, which I use best in quotes, is really more of a niche market when you get into high-rise buildings as well as window glazing, which are those high rises that you see with where the side of the building is all windows. And that gets really into more of a liability field, a liability issue with the performance of the sealant. So in that case, using something like a class 50 or a class 100/50 is much more critical to keep your window in place.
Great, thank you, Audrey. So at this time, there are no further questions. If you are interested in a sample or have questions about the materials that Audrey highlighted today, please contact your local account manager or reach out to our customer service team by calling our 1-800 number or visiting our website. Also, please remember to join us for our upcoming webinar sessions as we continue our spotlight on the adhesives market. I'd like to thank Audrey again for taking the time today to share with us her expertise on caulks and sealants. We look forward to seeing everyone on future webinars. Have a great afternoon.